Welcome, everyone. Good afternoon. We're just going to wait a few minutes to let some more people join the meeting. We'll start at approximately 12:05. Okay, good afternoon, everyone. Welcome, welcome. Looks like we are at enough of a critical mass here to start. My name is Nick Russell. I'm a specialist in the dredging, sediment, and ocean section of the Water Division here at EPA Region 2. Welcome to the first of two public scoping sessions being held by EPA Region 2 for stakeholder input to help us develop environmental review alternatives for the continued management of dredged material in the New York Bight. This meeting brings together port, estuary, coastal, ocean stakeholders together, and we're really excited to share with you and hear from you all. I'm going to go over some of the logistics of the meeting itself. So, as I said, the primary goal of this meeting is for you, the stakeholders, to provide EPA in helping us to develop an environmental review document that will consider the continued management of dredged material in the New York Bight. As you're probably aware, this meeting is being recorded. We are going to be using the transcript to compile verbal comments as well for our EA. Feel free to leave questions in the chat, but our verbal question and comment section will be after the presentation, so please hold your questions until the end. And also, of course, in terms of like regular netiquette, please remain on mute unless you are speaking. Let's talk about the agenda for the meeting itself. We're going to go through a presentation from us at EPA, as well as some of our counterparts at the Army Corps of Engineers, to go over the roles and responsibilities, a reminder of the process of the National Environmental Policy Act, historical background of dredging and ocean management of dredged material, the historic area remediation site and monitoring, and the need and request for ocean dredged material management from the Army Corps of Engineers, as well as the zone of siting feasibility and some of our thoughts on considerations for potential alternatives. And then, of course, we will get to the most important part, which is the questions and your comments. So without further ado, I'd like to turn it to Mark Reese of EPA Region 2 and Kelly Vega of U.S. Army Corps of Engineers, New York District.
Thank you, Nick. Good afternoon, everyone. My name is Mark Reese. I'm a marine environmental scientist and the supervisor of the Dredging Sediment Ocean section of EPA's Region 2's Water Division. I'm very happy to join my counterpart, Kelly Vega, from the Army Corps of Engineers, and welcome you on behalf of the members of our extended team who are also here today with us. So over the last 30 years, EPA and the Corps have been working together to remediate an area of impacted ocean bottom in the New York Bight apex, called the Historic Area Remediation Site, or the HARS. This area had been impacted by previous disposal activities, and the purpose of the remediation was to place dredged material as a cover over the impacted bottom. And we're meeting with you today because we're near the successful completion of this project, and we need to plan for how we're going to continue to manage dredged material into the future. In particular, that portion of the dredged material that we had previously used for the remediation project. The Corps is participating in this presentation and has accepted our invitation to participate in the overall process of selecting and evaluating alternatives as a cooperating agency under NEPA. And we look forward to continuing our partnership with the Corps into the future. So I'm happy to be able to speak with you all because the remediation of the HARS really couldn't have been accomplished by ourselves alone without the direct and indirect partnership and collaboration of many harbor and ocean stakeholders. So I just wanted to take this moment to sincerely thank the various entities that have contributed in many ways to the success of this project. But I'd like to specifically and especially thank the various organizations and individuals that have supported the HARS Scientific Review Panel. The Scientific Review Panel is a group of technical representatives from these various interested agencies and organizations who have faithfully met with us since the designation of the HARS to help us develop and review sampling and monitoring plans and data, and to engage in discussions about how those findings might translate into management strategies for the site. So again, it's been invaluable to us, and we just wanted to take this moment to thank everybody on that. So collaboration and partnership over the last 30 years in the dredged material management front has been really exceptional. There's been a lot of diverse partnerships in a lot of different areas that helped us successfully complete this project, but also we had a bunch of other notable successes that many people had a part in it and really could not have been done alone. And I just wanted to, call out a few of those things and highlight them. One was there was a huge investment in a very ambitious project using bi-state dredging money to to collect the data necessary to develop a system-wide model of contaminants in the harbor and that affected the ports and water quality and all those other related issues, which took a number of years. It was a very concerted effort. It was a lot of money, and a lot of people put in a lot of time, so that we ended up with a tool that was really valuable for informing management decisions about the system and how to address contaminants in the long term. And that's one very notable partnership that was very important during this time. In addition, on the management of dredge material, there was, a, a lot of dredge material was processed and placed over contaminated brownfields areas where we were able to address the contamination issues and restore that land to productive uses. Um, Dredge material was directed to daily landfill cover or for closure material for closed landfills. There was also quite a bit of dredge material that was used for resiliency and for addressing storm damage. We've had, quite a bit of material placed on the beaches to replenish beaches, to, create other recreational features like golf courses, and, very importantly, to enhance or restore habitats such as supporting artificial reefs or wetlands. So we've really had a really great track record working with other partners, and we've done a lot of great things together. And these various successes, really have only occurred because of the robust stakeholder engagement and collaboration that we've had over the years. So, so thank you all for being involved in all those other aspects as well. I did, take a look at the attendance list for folks that have registered for these two public meetings. And, I saw that there's a very broad cross-section of stakeholders represented. We have folks representing our shore communities. We have the recreational fishing and diving communities represented, commercial fishing and seafood industries, our coastal and ocean conservation organizations, and port and shipping interests. So we've got a really broad cross-section of perspectives on this. And, we also have a number of people actually representing, government agencies and both municipal, state, and federal. And, all of these perspectives are important for us, and we want to hear from all of you. So please share your comments with us either today or, at the information that we'll provide. There'll be a website. Please, feel free to submit there, or I guess it's actually an email address. Please submit via email. But, we do very much want to hear differing perspectives. And, we think that we'll have a better evaluation of alternatives if we do hear from many varied interests. So thank you again all for participating and being interested in this topic. And, so I look forward to talking to you after the presentation, and I'll turn it over to Kelly maybe to say a few remarks. So thanks again.
Thank you, Mark. Hi. So I also want to say thank you for attending the public scoping information session for the dredge material alternatives in the New York Bight. My name is Kelly Vega. I'm chief of the dredge material management section here at the U.S. Army Corps of Engineers and the New York District. In 2023, General Spellman sent a notification to the U.S. Army Corps of Engineers to expand the beneficial use of dredge material management program. And the two key priorities identified in this notification were partnerships and innovation. General Spellman also established a goal of 70% beneficial use of dredge material by the year 2030 for the Corps. And currently our district, New York District, has achieved 100% beneficial use of dredge material. To continue meeting this goal, the Corps has engaged in partnerships with stakeholders and NGOs to match dredge material from our federal navigation channels with projects for ecosystem restoration. So again, I would like to emphasize that the U.S. Army Corps of Engineers is committed to the beneficial use of dredge material. Thank you.
Great, thanks, Kelly. For those who joined the meeting after the start, I put some information into the chat. And I'd like to move on to help contextualize and define the different roles that EPA and U.S. Army Corps of Engineers play in the management of dredged material in the ocean. And when we're talking about the management of dredged material in the ocean, we are talking about the Marine Protection, Research, and Sanctuaries Act. The Army Corps of Engineers permits dredged projects in the waters of the United States under the Rivers and Harbors Act, but the transportation of that dredged material to the ocean is permitted by the Army Corps via the Marine Protection Research and Sanctuary Act. EPA develops environmental and testing criteria that is used to determine the suitability of dredged material for ocean management. The permits for projects, as I said, are issued from the Army Corps, and EPA must concur with the Army Corps in the determination of that material's suitability for ocean placement. Key to what we're talking about today, the EPA designates, manages, and monitors ocean dredged material management sites, and we work very, very closely with the New York District Army Corps in the management and monitoring of our dredged material management sites in the New York Bight. EPA also has civil and criminal enforcement authority under MPRSA. I'm going to now turn it to Ann Schaefer to talk about the National Environmental Policy Act.
Hi, everybody. As Nick just said, my name is Ann Schaefer. I'm part of the environmental review team at EPA Region 2. And I'm just going to talk a little bit about the environmental review process that we're following for this action. To start, a little bit of background on NEPA, or the National Environmental Policy Act. It's a federal law that requires federal agencies to assess the environmental effects of their proposed actions prior to making decisions. Using NEPA, agencies evaluate environmental, social, economic effects of their proposed actions and provide opportunities for the public to review. Depending on the action and the scale of the impacts, agencies generate a written report called an environmental assessment or an environmental impact statement, which is made publicly available. In the reviewed document, federal agencies provide the purpose and need of an action, a range of reasonable alternatives, an evaluation of the affected environment, and an analysis of effects. The NEPA process includes both stakeholder and public involvement at various stages. Although not required because of the MPRSA's site designation evaluations that are required and determined to be functionally equivalent to NEPA reviews, it's EPA's policy to prepare voluntary NEPA documents for ocean dredged material management site designations under the MPRSA. So just to give a little timeline for this NEPA review, we're now in the public comment period for the scoping phase, which began with the notice of intent being published in the Federal Register and will last 30 days until July 14th. As is standard for the scoping phase of a project, EPA is holding 2 public meetings to provide information on the project and to solicit input on the environmental impacts and the potential alternatives. After the scoping period's over, EPA will consider the comments and move forward to prepare a draft NEPA document with help from cooperating agencies. When complete, a notice of availability of the draft NEPA document would be published in the Federal Register, which would begin another public comment period, which would either be 30 or 45 days, depending on the level of NEPA review. Additional public meetings would be held at that time. Finally, after comments on the draft document are considered and addressed, EPA will finalize the document and publish a notice of availability of the final NEPA document in the Federal Register. With a final EA, a FOMSI, or a finding of no significant impacts, is also published, and with a final EIS, a draft record of decision would be published. Our anticipated timing for these different steps are shown on the slide. You just go back, yeah. Again, the comment period for scoping ends on July 14th. We are anticipating a draft NEPA document will be published sometime in September of this year, with a final document being published close to the end of the calendar year. And concurrently to this NEPA process, the MPRSA also has its own rulemaking process that would include a public comment period after the publishing of the draft rule. So additionally to the requirements of NEPA, EPA is also required to ensure the project complies with various federal environmental laws as applicable. These include the Endangered Species Act, National Historic Preservation Act, as well as some others. EPA will be working with resource agencies and interested parties to ensure compliance with these.
Okay, hi, I'm Pat Petchko. I'm a physical scientist with EPA's Dredging Sediment and Oceans team. And I'm just going to give you a little quick background on some of the historical ocean waste management in the New York Bight. And I've entitled this slide specifically Historical Waste Management for a good reason, because back in the 1800s, most of you know the ocean was actively used as a dumping ground for many wastes, including things like acid wastes, industrial wastes, paints, chemicals, manufacturing sludge, sewage sludge, cellar dirt, wood incineration. You can see some of the dump sites, the more recent dump sites. And by recent, I mean 60s and 70s on the map to the right-hand side of this slide here. So in the New York, New Jersey harbor region, the port's not very deep. It's only about 19 feet deep. So for a long time, we have had to place dredged material along with these other wastes into the ocean. So I'm not going to go through the entire timeline shown here, but you can see that there's been really a nice progression in recent years, beginning in 1972, for a few decades, regarding ocean protection. Back in the 1880s, early 1900s, everything was dumped out there. 1972 came along, Marine Protection Research and Sanctuaries Act began regulating ocean placement. We had final regulations enacted shortly thereafter. In 1984, most of you will know that we had the mud dump site. That's the site. And I don't know, can you see yeah, there you go. Someone's got a pointer. Great. That's the mud dump site. That was used from 84 until 1997. It was officially designated as a dump site. I did mention that we had lots of other wastes being disposed of in the ocean. The Ocean Dumping Ban Act of 1988 came along, and basically made the dumping of those types of things unlawful, so that presently the overwhelming majority of material placed in the ocean is clean dredge material. There are a couple of other things that are allowed, like burial at sea and marine mammal carcass disposal, but nothing, there's no acid waste, there's no sewage sludge, there's no medical waste, nothing like that. Really, the majority of what we do, particularly in the New York Bight, most material is clean dredge material. I want to stress that. Okay, can you go to the next slide, Nick? So the mud dump site, which was that box you saw, was started to get used in 1914, and as I said, it progressed through to 1997. But during the 80s and the 90s, there started to be heightened concerns about the historic and ongoing placement of dredge material and the impact to the marine environment. So in 1995, EPA began to study the area surrounding the mud dump site to evaluate the impacts and consider remediating those impacts. In 1997, the HARS, the mud dump site, was closed, and the HARS was designated, that's the Historic Area Remediation Site, was closed to address documented adverse impacts that occurred from prior ocean placement of those wastes. Essentially, in 1996, there was a letter signed by the Secretary of the Army, the Secretary of the DOT, the Administrator of EPA that says close the mud dump site and simultaneously designate this 15 nautical mile square area called the HARS to reduce the impacts to acceptable levels. Acceptable levels, the remediation would be done by placing at least 1 meter of clean remediation material over the entire HARS, which is that box you see there, that larger box there. Remediation material would be that which met current Category 1 standards and will not cause significant undesirable effects, including through bioaccumulation. So that was in 1997. Closed the mud dump site, and we opened the HARS, remediated it with remediation material. We had changed some of the standards, tightened up the standards, but we didn't walk away at that point. In 1997 to 2003, we had a scientific peer review process, which resulted in further revisions to the criteria for the acceptability of material for placement at the HARS. So we just didn't go in and designate. We revised it with a scientific peer review group. Next slide, Nick. Okay, so just a brief explanation of the HARS. This is a little bit closer up. You see that there are 9 priority remediation areas. Those are the areas that received the 1 meter of remediation material, where we had demonstrated that there might be some adverse impacts from prior disposal. Within those, you see those round circles. Those are shipwreck buffer zones that were put in place because of a potential or actual presence of shipwrecks. So we didn't want to impact any archaeological, anything of archaeological value. So you've got your shipwreck buffer zones there. Around the entire site, there's a 0.25 nautical mile buffer zone that allows for dispersion of materials that might leave the site. We do address that and try to not use that buffer zone, but that is in place to address that. And there is a no discharge zone in the middle that's too shallow for us to place materials. So you've got a number of management areas within the historic remediation site. You do see 2 circles down at the bottom, capping projects. 1993 was, there was a concern over some of the projects that may have been disposed in that time frame, and they were placed there and capped. In 1997, that 3-party letter that I mentioned earlier did allow projects to go out that wouldn't meet the 1997. They had a 12-month window for the port to be dredged, where there was a phase-in of criteria. That's that material that was also then capped with clean material. So I'm going to turn it over to Jordan Wellnetz, who is going to give you some background on HARS site management and monitoring, the good stuff. So Jordan, take it away.
Thanks, Pat. So as Pat said, I'm Jordan Wellnetz. I'm also with EPA's Dredging, Sediments, and Oceans section, and I'm heavily involved in the monitoring efforts out at the HARS. So I'm going to talk through some of our approach to management and monitoring at the HARS, and some of the things we've learned over the course of the last 28 years. So first, MPRSA requires that a site monitoring and management plan, or SMMP, be drafted and implemented for all ocean dredge material management sites. The SMMPs are reviewed and revised at a minimum on a 10-year cycle, and the most recent revision for the HARS was in 2020. The SMMP spells out specific guidelines as to how to monitor placement activities, assess the progress of remediation, analyze environmental conditions at the site, and address any potential environmental issues. In addition to this, we have a panel of port and ocean stakeholder representatives. As Mark mentioned earlier, this is the HARS Scientific Review Panel that we meet with at least annually to provide technical input on EPA and Army Corps monitoring and management efforts. So before being approved for use as material for remediation, this was touched on a little bit earlier, but I just want to highlight again that before anything's approved, proposed project dredge material is sampled and rigorously tested following EPA and Army Corps approved physical, chemical, and biological testing procedures. Material can only go out to the HARS after a dredging project has met the stringent criteria and is approved for HARS remediation. After this point, placement grids are developed to designate specific locations at the site for managing each project. So on the next slide, I'm going to briefly walk through a project example to see what management of material at the site looks like in practice. So here, the first image we see is where a placement grid was created for a specific project. The size and the location of the grid is based on the physical characteristics of the project material, the anticipated volume of the material, and the thickness of remediation material that's needed to provide 1 meter of cover at that location. So scows are given specific cell locations within each grid where they're directed to place the material from each barge. Here you can see in the track lines from one barge trip out to the Hars, the track lines are in black with the actual placement shown in red, and that's when the barge was actually open. Here at the next image, the barge mounted draft and position recording equipment and third-party inspectors are used to ensure strict compliance within the placement specifications. So in this image, you can see a snapshot from the tracking software that shows the speed of the vessel in red and the draft position in blue. Starting on the left side of the image, you can see that as the scow is being filled, you can see the draft increasing in that blue line. And then as it transits out to the Hars, it remains stable. And then there's the large change in draft position that shows the actual release of the material. And this software allows us to track for compliance and also can be used for enforcement to ensure that material is being placed where we specify it should be. In the next image, you can see what it looks like once all of the placements are complete within the grid cells. So we can see here that we're achieving very precise placements within each of those cells. And lastly, you can see a comparison of the same area looking at bathymetry. So in this example, the material that was placed out here was very coarse, rocky material. And in the bathymetry, or actually what we're seeing here is the backscatter, you can distinctly see where the placements occurred, the raised features along the grid. So following project placement, EPA and Army Corps regularly monitor sediment conditions in areas that have recently received 1 meter of remediation material. So we go out and collect samples of sediment and resident worms and analyze them for key parameters to ensure that concentrations remain below HAR-specific thresholds. The map on the right is just an example of post-remediation sampling conducted in areas that have recently received at least 1 meter of material. So the area in green across the footprint of the site is showing where at least 1 meter of material has been placed. And you can see some of the targeted sampling locations sort of on the eastern portion of the HARS. So this sampling cycle, that's where placement had most recently occurred. If we find that contaminant concentrations approach HARS-specific quality guidelines in resident worms at any one location, an additional meter of remediation material is directed over the surrounding area. And we use 75% of HARS guidelines as the threshold for this sort of adaptive management approach, where we will place an additional lift of material. And typically that material is sand. So additionally, high resolution bathymetry data is collected annually across the entire HARS to determine the physical distribution and thickness of remediation material after its placement at the HARS and to assess remediation progress. The figure on the left is showing bathymetry from 1998, which is shortly after the HARS designation. And on the right, this is bathymetry from last year, from 2024. Comparing the two, you can see all of the changes in bathymetry that show where material has been placed over time. It's easiest to see on like the western and eastern margins of the HARS, but if you look closely, you can see the change in bathymetry that we've achieved over time. So progressive management of material at the site has created a patchwork of areas of different material types across the footprint of the HARS. This is largely due to the sequencing of projects. So when different material from different projects become available, and also dilution requirements. So that allows for coarser material like rock to be placed along the margins of the site because the material doesn't spread out after placement. So we wouldn't have material going into the buffer area outside the HARS. The figure on the right is just an example of the patchwork of different projects and material types that have been created over time. And in the bathymetry on the left, you can see some of these same projects. So in some areas, the placement of deepening materials like mixed glacial till, rock, and clay have created elevated bottom features with substantial vertical relief. So comparing the two images, specifically, you can see the orange areas on the figure on the right. And comparing those to the bathymetry on the left, you can see, so that's where some of the vertical relief is coming from. And a project that's not highlighted on the right, but it's a prime example of this, is looking at the western boundary of the HARS. This is an area where rock from harbor deepening projects was rejected initially from artificial reefs and was placed out at the HARS. And you can see pretty clearly the vertical relief that's created on the western part of the Harz. So on the next slide, taking a closer look at some of the rocky areas along the western margin, monitoring at these areas has shown that these features have been extensively colonized by a variety of organisms, and we've inadvertently created habitat and structure for fish, for other benthic organisms. In these images, you can see corals, sponges, other encrusting organisms, some fish, and it appears to have provided good quality habitat for structure-associated fish. I will also say, after spending a fair amount of time on survey vessels studying the sediments at the Harz, this area sees heavy utilization by recreational anglers as well. We see a lot of fishing boats out here while surveying each year. On the next slide, we see a similar story in areas that have had placement of glacial till, so mixed variety of different rock sizes, rock, cobble, pebble, gravel. And again, we're seeing things like sponges, corals, fish, sea stars. And the next slide, we've also found in our monitoring that placement of red clay has seen colonization by a diversity of benthic organisms as well. It's a little bit harder to see in these images, but on the right, the dark rocky looking material in that image is actually a lot of small mussels that have encrusted on the clay. So we've seen some real benefits to management of native materials at our site over time. So before we get into some of the options for future management of material, I just want to summarize some of our bigger takeaways from the last 28 years of management and monitoring at the Harz. We've been able to achieve very precise management of material. As you saw in the placement grids, we've verified over time that we can keep placements very restricted to specific areas. Material, once placed, has remained stable. We haven't seen large-scale movement or loss of material outside the site, including following storm events. Instead, we're seeing long-term stability of this material. We've had a lot of success with meeting our remediation goals, and our approach to post-remediation monitoring and adaptive management and the targeted additional lifts in areas that have exceeded 75% of criteria has worked to keep contaminant concentrations below our thresholds. And lastly, the benthic habitat creation I highlighted earlier. In addition to remediating this area that's impacted by historic disposal activities and reducing contaminant concentrations, we're encouraged to see this kind of benefit, and it's inspired some of our management considerations for the future. And so lastly, where are we now? So to date, approximately 89 million cubic yards of dredged material from the port and its surrounding areas have been placed as remediation material at the Harz. In the map on the left, you can see in the green layer that most of the Harz has been covered with at least 1 meter of remediation material. The remaining remedial capacity is extremely limited. Based on 2024 bathymetry, we estimate that we have approximately 5 million cubic yards of remediation capacity left, and maybe an additional 4 to 5 million cubic yards of adaptive management in some targeted areas as well. But that's why we're here today, to discuss options for continued ocean management of dredged material as we're running out of remedial capacity at the Harz. And with that, I'm going to pass it to Arsheen Etisham with the Army Corps of Engineers.
Hi, good afternoon, everybody. My name is Arsheen Etisham. I'm a geologist with the Dredged Material Management section at the Army Corps of Engineers, New York District. I work with Kelly Vega, who you heard speak earlier, the chief of our section. So for our short presentation today, we'll quickly talk about our request to EPA for an ocean dredged material management site and what components included as part of our request. Next slide, please. Oh, thank you. So we prepared our request and we submitted it to EPA in June 2023. As you were seeing from the previous slides presented by Jordan, as we monitor and manage the site, we were observing that we were approaching that point of completion of remediation. So at the Army Corps, we thought it prudent to evaluate and send this request in June 2023. As part of our request, we included an evaluation of the kind of volume that we generate from dredged materials. We also looked at different placement sites, including the Harz, and the capacity at those different sites. as well as a zone of siting and feasibility. And that includes looking at where within our area, within the New York Bight, it might be feasible to site a future site if possible. Next slide, please. So as I mentioned, we looked at dredge material volumes and we looked at the history and we looked at some projections. So historically, as Pat had mentioned earlier, the site was designated in 1997 and we started placing material there in 1998. So from then on, from 97 to like 2022, we looked at a variety of different placement, what kind of volumes we had. We looked at projects coming out of our operations and maintenance here in Army Corps, our new work construction projects. You may have heard the phrase harbor deepening mentioned earlier. We also looked at our private permitted projects and what kind of volumes were coming out of all of these different projects over that historic time frame. And we noted that around 83 million cubic yards of category 1 dredge material was placed at the HARS. So looking at this evaluation, we know what we're expecting maybe over the next 20 years. We use that same analysis and we understood that for the next 20 years, we were expecting around 51 million cubic yards. So that's, looking forward, 2025, 2022, 2043, we were expecting around 51 million cubic yards. The image on the right over there, the image on the right just shows you all the different federal channels that New York District is responsible for maintaining as part of our area of work, our AOR. Thank you. For the next slide. I know. The other part of our evaluation was also looking at placement location. So on the left-hand side is that similar image that you've seen already of the HARS and that green showing the area of the areas where remediation was completed. I do want to note that, these are the images that I used here and some numbers that I used here. They're from the time that we made our request to EPA. And as you can see, between our request and from Jordan's previous slides, there have been some changes. So we have continued to place material. So some of those estimates that we're seeing there are slightly different. So at the time of our request, we had initially estimated that there may be 6.5 to 7.5 million cubic yards of remaining capacity. But as we study and continue to manage and monitor the HARS, we see that that number is changing and we're placing material there as well. And we see that that's impacted that remaining capacity amount. We also looked at what our options were when it comes to upland and non-ocean placement. So we looked at a whole lot of different sites. That little box on the bottom right there tells you the different types of sites that we looked at. So in terms of upland, kind of goes back to a little bit of what Mark was talking about. This can include, placement at landfills as landfill top cover. We looked at confined disposal facilities. We also looked at beneficial use of this dredge material for environmental projects, maybe restoration for degraded lands, beach nourishment. And with all of this, we did an evaluation to find that we're looking at approximately 22 million cubic yards that may remain for these different types of upland and non-ocean placement. But it should be noted that placement as part of upland and non-ocean areas, it's just an order of magnitude higher. And we estimate that, that 22 million, it will continue to go down as well as these sites are they're being continually used as well. And placement continues to happen at those sites too. Next slide, please. So, so as part of that, we saw that we had an evaluation where we need around 51 million cubic yards. We're expecting that over the next 20 years. We're looking at what's remaining at the HARS in terms of placement, what's remaining at the upland sites. It kind of all led us as well to evaluate our dredge material management here in the New York District. We conducted our own separate effort of looking at what we can expect as part of dredge material management over the next 5 or so years. So here in the New York District, we prepared our 2025 dredge material management plan. It's an update to a previously existing plan. And as part of this effort, we ourselves, we did public outreach. We reached out to some of those permitted folks that we talked about earlier and to kind of assess what exactly are we looking at in terms of regional dredge material placement demand and capacity. How many people and how many groups want to place material and what kind of capacity are we looking at? So this evaluation at the end of this, it also confirmed the need for additional ocean-based dredge material management alternatives. We are currently in the process of completing out this report. The draft report is available, and we soon hope to publish the final report on our website. The key takeaway that we noted here is that our current federal standard for Army Corps New York district placement continues to be the placement of dredged material at the HARS. And we continue as a result of this evaluation to project a need for additional placement capacity over the next 20 years. Next slide, please. So, we've identified that there is a need here, and we would need to find a place to have a site or potential location where material may be placed. And as part of understanding where this may be possible, we did a zone of siting and feasibility analysis. So as part of this process, we used to, it was helped to determine what kind of a radius the Army Corps could work in. Like what would be a feasible radius for us from an operation standpoint and from an economic standpoint. So knowing we have a lot of different projects out there in the New York, New Jersey harbor, we took two kind of like representative projects here with different types of volumes. So a typical maintenance project we would look at with around 200,000 cubic yards, and then maybe a newer construction project, which might be a bit larger, looking at 2.5 million cubic yards. And we use these as representative case studies for our evaluation. Next slide, please. So I presented here two different sides here. So on the left-hand side, we'll talk first about the operationally feasible radius. And what that is that for Army Corps, we looked at things like how long it takes to load a scow. We looked at how large a dredge bucket might be. How long does it take? And what kind of barges, what kind of scows do we have? And how long it takes to go to the HARS and come back. And just kind of understanding from an operational point of view, what is that radius that would be a feasible radius for us to still continue to maintain our federal channels? And as a result, we kind of identified a 40-mile radius exhibited on the image on the left there with that red line that you see that would still allow us to continue to be operationally feasible and continue to do our maintenance work in the federal channels. And on the right-hand side, then I'll kind of pivot over to the economic side of it. So economic feasibility here was determined by looking at all those operational factors along with looking at total project costs. We have our independent government estimate calculator that we use, CDEP, and we use that to kind of see where we are when it comes to the costs here. So there's a small summary table on the bottom right there, where we took approximate cost difference of maintenance projects that we talk about, and like the material coming from new work projects, and how the cost changes when we are talking about placement at the HARS, that ocean alternative, the ocean spot that we are talking about, and upland, those different upland sites like landfills and so on. And we see that when we talk, and we use like volumes that we were projecting, that 51 million cubic yards that we're looking at over that 20-year horizon, took the per cubic yard that we might see, and then did some math over there to come up with some of these numbers here. So, for example, for a maintenance project, where if we're placing at the HARS, at that rate of like $18 a cubic yard, we might be looking at $469 million. But when that same material has to go upland now, it's a lot higher. It's around 2 billion or 4.8 to 4.8 billion. Similarly, with the new work and glacial till and rock, we see that similar increase as well. So with our identification of that radius, we passed this request on to EPA. And from there on, EPA kind of took us identifying this 40-mile radius to do further evaluation. And I think with that, I can pass it on to our colleagues back to EPA, who took our zone, that 40-mile radius, and continue to do some more evaluation of that. Thank you.
Hi, my name is Lindsay Adamczyk, physical scientist with EPA Region 2 Dredging Sediments and Oceans section. I do a lot of data management and GIS for our dredging and site monitoring work. And so I'm going to talk about some of the initial work that we did in response to that request that Arshin just talked about. So that request established a few things. First of all, it established the need for an ocean site for the management of stringently tested and approved dredge material. It also established that site would need to be located somewhere within the zone of siting and feasibility, which Arshin just talked about and is also shown here in red. So in looking at this New York Bight ZSF, We know it's a busy place. It's full of shipping, fishing, habitat, cultural resources, etc. And in thinking about a potential dredged material management site, we would want to minimize any potential conflict with these current existing uses of the ocean. So to think about minimizing these potential conflicts, we did a preliminary screening using publicly available data, which you can see on the map here. I will detail it a little bit more in further slides, but for now, in looking at just all of this data overlaid on each other, you can see that some of the areas that are still showing the gray of the background do appear to minimize conflict. And the three largest of those areas are outlined here in pink and labeled A, B, and C. So just to be clear, these boundaries are not any sort of potential sites. They are areas within which a site could theoretically be located, and they are areas of interest because they minimize conflict with existing uses of the ocean, at least according to this preliminary data screening. So the next slide looks at one of the first data sets that we looked at, which is a depth limitation. It was derived from a regional bathymetry data set. And the goal is to make sure we avoid any locations that are too shallow for a dredged material management site, basically avoiding a spot where mounding material would potentially cause a navigational hazard or the possibility of resuspension of material. So all of the areas that are shown in brown here are excluded from consideration for a potential site. Then the next slide will look at some of the data sets to do with navigation and vessel traffic. So these are things like shipping lanes, anchorage areas, high vessel traffic areas, essentially all of these areas of higher traffic where we would not want to interfere with dredged material management operations. Next slide goes through resources and obstructions. So these are things like lease areas, borrow areas, cable routes, cultural resources like shipwrecks. Once again, things that we would avoid conflict with. And then the next slide goes into habitat. So here we're talking about marine protected areas, artificial reefs, this canyon feature that you can see between areas A, B, and C there. And once again, just looking at features that we would be avoiding in potential dredged material management site. So yeah, so again, all those three boundaries were created from overlaying all of those data sets. And then we also wanted to look at fisheries data. So we overlaid them on these different data sets here. In the top left, you see New Jersey prime fishing grounds. And then the bottom right, you see vessel monitoring systems or VMS data. This particular map shows all VMS data. The blues and greens are areas where vessels are spending the least amount of time. The red is where they're spending the most amount of time. And while this data set is sort of a compilation of all the fisheries that the VMS data looks at, we also did look at individual fisheries listed on the slide here. And so any of this data would certainly be considered if a site were to be selected within one of these areas. So I think that wraps up everything I wanted to talk about in terms of narrowing down that ZSF that was presented to us in Army Corps' initial request. So with that, I will pass it on to Mark Reese.
Thank you, Lindsay. So obviously, quite a bit to digest here. But we've learned a lot. We've done a lot of preliminary work in understanding where we can cite any alternatives for continuing ocean management. And I just want to describe some potential alternatives that we are considering and that we'd like you to think about and ask questions about and understand what we're thinking about. And if you have any other suggestions, we're eager to hear about those as well so that we can consider those in our environmental review. But in developing some of these preliminary alternatives that we're considering, we had various considerations that guided us in addition to the siting that we just talked about and trying to employ the lessons that we've learned from our monitoring over the years. So the first thing that I guess I wanted to put out there is that, there are no relaxations of the standards being contemplated. What we are being asked to provide for and what we are trying to address is continuing management of the dredge material that is currently being managed at the HARS. We are not looking to expand to allow additional, more contaminated material to go in there, nor are we looking to restrict it. We are simply trying to address continuation of operations so that we can continue to have predictability and we can continue to ensure that, we're meeting the environmental goals that we want for the system. So there's no relaxation or change to the standards being contemplated. The second thing, as we go through the alternatives, we are going to be looking at the impact or the benefits, in fact, associated with any alternatives that are evaluated during our process. And then the last thing sort of that we had to keep in mind was, what is the ask? Over the next 20 years, there's going to be 51 million cubic yards. How can we best manage that material? We have to understand, when that material is going to be generated and what that material is going to look like. So importantly, the breakdown of the 51 million is important to think about. And that is, there's 29 of the 51 million cubic yards is going to be generated from maintenance projects over the next 20 years. Maintenance includes maintenance of the channels that come in through the Rockaway Sandy Hook transect, and much of that material is sand. So we expect 3 million of these 29 million cubic yards to be sand material. 22 million cubic yards is anticipated to be generated of native material from the harbor besides those sands that we talked about. We're talking about material from deepening. So from these harbor improvements, the deepening and widening of the channels and the berthing areas is going to dig down below the muds that are accumulating and would be part of the maintenance material of the harbor. We're going to be digging down into other materials like tills and clays and rock materials. And so about a quarter of this 22 million cubic yards is going to be non-sand material, non-rock material, hard rock that would be slated for artificial reef, what we call moderately hard rock or clays or tills. And these materials would have been in the past managed at the HARS. So really that 22 million reduces further as to what we're talking about here. Next slide, please. So some of the alternatives we're looking at, sort of broadly speaking, is, as part of NEPA, we must consider the no further action or the no action alternative. And so in this case, that would mean that we would complete the remediation of the HARS, and then we would take no further action. We would not provide an ocean alternative for managing dredge material. That has sort of been discussed previously, and the need for ocean management for the material that had, for the class of material in the future that can be generated that has previously been managed at the HARS has already been discussed, and it brings us to this undertaking or to this evaluation of alternatives. So it will be retained in the NEPA analysis as a point of comparison, and the environmental aspects of it will be discussed. But the other option, sort of on, if you will, the other extreme, would be to just go to those polygons that Lindsay showed, that she derived and identified, where there's, we minimize conflict, and to just designate a dredge material disposal site outside those HARS boundaries, but within those polygons. However, the governing regulations that implement MPRSA, require that wherever feasible, EPA is to designate any new sites within areas that have been historically used for waste management. So essentially, we're not intending to look at that any further, although it is an alternative. The regulations, discourage that, and so we would not be looking at an actual disposal site outside the HARS boundaries. A little bit different sort of twist on that we're looking at, which is looking for beneficial use opportunities in the New York Bight, in that zone of siting feasibility. but outside the HARS. And there's two types of things that we're considering and preliminary looking into the basis for. And that is the answering the question, are there other areas within the zone of siting feasibility that have been impacted by past practices or by other environmental conditions that might be worthwhile to designate so that we could remediate that site and improve conditions there using HARS quality dredge material. And then the second would be looking for opportunities for habitat enhancement somewhere within the zone of siting feasibility or within those polygons more specifically, because of what we've learned within, from all our monitoring within the HARS, that we believe that there's opportunities to, particularly when we talk about the deepening material or the sand materials that might come out of some of the maintenance projects, that we may have the opportunity to use it more beneficially to create habitat. So I'm going to discuss some of those alternatives a little bit more closely, at least, on a cursory level, to describe them a little bit so you can understand them. And then the last option would be modifying the designation of the HARS itself to allow continued use after remediation. So when we talk about, remaining capacity or remaining material that can be managed at the HARS, we're talking about sort of the remedial capacity, how much to place 1 meter of material is left. But there's still, if you will, overhead capacity before we run into concerns about the stability of the material on the bottom. So there's an opportunity to continue to place material beyond that 1 meter and still, maintain, all of the other goals that we have for site management. So really, there's sort of two ways that we're contemplating looking at that. One would be sort of redesignating a portion of the HARS and managing all of the materials in one place within the HARS. That has some sort of practical benefits in terms of management and monitoring. So, we are going to consider that. We are going to be doing projections on how large of a portion of the HARS that would be. And then the second would be to manage the muds in one area of the HARS, and then to manage the deepening and native materials separately. And that might, allow us the opportunity to create habitat within the HARS and sort of enhance the remediation that we've done with some actual habitat enhancement. So if you will go to the next slide, I'll talk about some of these a little bit more. Looking at the beneficial use opportunities outside the HARS, I already sort of described it, that the idea would be to look for other areas that have been impacted. So since 2021, EPA during its monitoring activities in collaboration with the Corps has gone out and has conducted a lot of sampling in the areas. Nick, maybe you could zero in on the areas between the sewage sludge site and the HARS. So we've done a lot of sampling there in the canyon areas closer to the areas that have been managed, used to manage materials historically, which includes the cellar dirt site, to the west, and the sewage sludge site to the east. So we've done some sampling in there, and then we've also looked for fine-grained sediments because we know that that's where the contamination would be present within the polygons. And we identified fine-grained sediments in areas A and B, and we've conducted some sampling there as well to assess conditions there. And we're going to further evaluate, the potential for remediation during this process. But I will share that, our preliminary review and review of the data, suggests that conditions in these areas really can't be improved by the placement of HARS quality material. Okay, if we can go to the next slide. Another beneficial use opportunity is really to take the lessons that we've learned about this sort of incidental creation of habitat within the HARS, that sort of arose, as Jordan explained, by the sequencing of projects and the dilution requirements, resulted in this patchwork. And going back, it's clear that it's functioning very well as a habitat. We've done some comparative studies so that we know that this is very good quality habitat that we've created with a diversity of types of material. But again, we're talking about the native materials that have come out of deepening projects. And, but we wanted to retain the possibility of perhaps using this material intentionally to create fishery enhancement features. So in the intervening years between the Corps' request for a site And now we've met with a number of people, fish biologists, fishery and habitat managers, fishery management councils, commercial and recreational fishermen, to explore sort of their feelings about this concept and whether or not there was an appetite for this. And basically, there was general support for the concept, but there were some concerns about how this would be. There's a lot of unanswered questions, I think, about how this might be constructed. I think the answer on how it might function, I think we can get some of that information from the existing features, but probably some additional questions and reservations about how it would be constructed and where to construct these features. So if we can go to the next slide. Our inspiration for doing something outside the site was, a recognition that up and down the Atlantic coast, there's naturally occurring shoals that are associated with previous stands of sea level. Many of these are sand shoals, but they occur up and down the coast, and and they've been designated as essential fish habitat. They are differentially used and preferentially used by a variety of fish species. Many fishermen, both commercial and recreational, target these banks and shoals, or bumps or whatever they might refer to them, as sort of attractive fishing areas because of their ability to retain fish and attract fish. So, despite their designation as essential fish habitat, many of these, in fact, are impacted by sand mining and infrastructure projects up and down the coast. And we thought, sorry, let me explain the figures first. The figure on the left is actually off of Delaware and Maryland, but this is a portrayal of the bathymetry using actual bathymetry, which clearly shows these series of shoals that exist. And features like this are up and down the coast, including in the New York Bight apex and including in the zone of siting feasibility. We can see them south of that area B. And we can see them out to the east, south of Long Island. So these features exist, perhaps not as densely as what we see off of Delaware and Maryland in the left-hand picture, but they do exist and they continue up into here. And so we thought that, based on what we've seen on the incidental placement of this, that maybe we would want to undertake an intentional project in which the deepening material. So again, we're not talking about maintenance muds here. We're only talking about the deepening material. So this really isn't a standalone proposal. We still would need to have an answer for how we would manage the muds. And that could bring us right back to, requiring some modification to the designation of the HARS itself to accept those muds and manage those muds. So if you could advance the slide. I just wanted to share this, that in our conversations with the folks, and I think there was a little bit more reservation amongst the fishermen that they wanted to know a little bit more about the specific location where these things might be constructed. But from the fishery biologist point of view, they thought that the best location of those three polygons for construction of a fishery enhancement feature would be within B. And they had a variety of reasons for that. But what I wanted to do was just sort of share a sense of the scaling of what one of these things would look like if, in fact, the decision was made to construct one rather than several. That is an actual shoal that Lindsay, with her GIS talents, was able to lift and make calculations to estimate the volume of, and that overlay of a shoal onto area B shows you more or less the scale of a feature that's between 10 and 20 million cubic yards. And again, I think of the types of material we're talking about, that's more or less the order of what we would be talking about. So that's more or less what the habitat outside the HARS that we've been thinking about and are contemplating for further evaluation in this process. Moving on to the discussion about modification of the HARS designation, I think we would need we've done some initial explorations to understand and modeling to understand what areas would be required under the various scenarios. But basically, we still need to, under this evaluation alternative, specify the area of the HARS that would continue to receive dredge material above the targeted 1 meter of cover. We, based on our monitoring, we've done a lot of work looking at the shipwreck buffer zones, the conditions within those zones, and in fact, the evidence for actual shipwreck debris in those sites. There are two in particular that we are, contemplating modifying the designation to remove those shipwreck buffer zones based on our monitoring information, and we will be considering that as one of the alternatives for how we might modify the HARS designation. And those two are you can go ahead and show them, Nick. It's that one and the one up in PRA 9. Those two, there's really no evidence that the shipwreck buffer zones are in fact justified. Well, if anybody wants to discuss it further, they can. But essentially, when these things were specified, there wasn't very strong information about the presence of actual shipwreck buffer zones. In some cases, these were specified because those were the coordinates of the last sighting of a boat or something like that. But we've gone back and done, work looking at them to see if there's any debris in there. We've determined that there is not any debris in those two. The other two shipwreck buffer zones, we confirmed that there are in fact shipwreck debris present in those. So we're not contemplating any change to those protective areas. And then the last thing, and I've just taken that shoal and superimposed it, but what we are thinking is that there's also the potential to never leave the footprint of the HARS and to conduct the habitat enhancements within the footprint of the HARS itself. Again, one shoal like that, may not be what is ultimately chosen as the preferred way of doing it. I think, that's really the last slide I wanted to share. But what I wanted to emphasize is that, as I said in my opening remarks, the role of the scientific review panel has been critical for us to, sort of clarify what the management and the monitoring questions are. We think in any way moving forward that we would continue to maintain a healthy, robust relationship with the scientific review panel, and particularly when we get into questions of habitat enhancement, where it sort of takes us outside of our own areas of expertise. We would look to expand the scientific review panel and include more people who are, have fishery biology and ecology experience, fishery monitoring experience, and in fact, fishing experience. So we would want to include stakeholders from the fishing communities, both recreational and commercial, to help us, better inform how we should, go about monitoring and answering some of the questions about constructing these things. So I think that's my last slide. So thank you very much for your attention, and I'll turn it back to Nick.
Great, thanks, Mark. Okay, so as you've heard through our many presenters here, we're seeking your scoping comments and input to support the preparation of the environmental review. Please submit your written comments to the email that's listed here. It is also on our website, which is on the bottom of the slide. The email is region2_mprsa@epa.gov. In just a moment, I'll also put the link to our website in the chat, which is where you can find links to the Army Corps' request for an ocean management option, as well as the slides and the recording of this presentation, which will be posted after the meeting. Please note that all comments are due by Monday, July 14th, 11:59 p.m. And again, please submit your written comments. At this time, we'd like to open up the floor to verbal questions. We'll be monitoring the chat as well. So if for any reason you can't speak, you can put your questions in the chat. However, I will ask that anyone who has a full written comment, again, please submit it to the email address on the slide here. Without any further ambling, please go ahead and raise your hand, or go ahead and unmute yourself if there's no hand raised, and we'd love to hear any of your thoughts. Yeah, Scott.
Great. Can you hear me?
Yes, sir.
Okay, perfect. Scott Mackey here on behalf of Garden State Seafood Association. We represent the commercial fishing industry of the state of New Jersey. I want to thank you all for this presentation and sharing this information today, and we will provide written comments by the 14th as well. Just a quick preliminary comment. Look, we are facing, as a commercial fishing industry, cumulative impacts with property that's been set aside for offshore wind, for new transmission systems, for the continuation expansion of beach replenishment and the taking of the shoals off the coast. All of these things are having a huge impact on our commercial grounds, historically sand-based bottom, where flounder, quahogs, clams, scallops have all been dredged. And obviously more material that goes out and is put on new sites becomes problematic for us because it's basically fishing ground that historically we've been able to fish that we will now lose. So I do ask that you try to focus on existing structured locations, existing reefs. Potentially, if there's ever a windmill site built, there's going to be tons of new structure put down there. Obviously, anything that we can do to minimize additional structure, we would be supportive of and are concerned about all of the structure that is going out there and impacting our fishing grounds, historic spots negatively. So I will stop there for now.
That's great. Thank you so much, Scott. Jack. Jack, you're on mute at the moment. Does EPA want to respond at all to Scott's comment? I think we understand.
I would just say, thank you, Scott. That sort of mirrors some of the concerns that we've heard from other fishers that siting is of paramount importance and noted.
Is the dredge material to be dumped on a new polluted bottom area, or is New York just looking to get rid of dredge material in the cheapest way? Huh.
So
did you hear that? Did you hear that?
I did, Jack. There's, as outlined, we're considering all alternatives at this point. I think that it's clear that the regulations have a preference for using existing sites and previously used sites. So, that is going to be one of the considerations when we weigh impact and benefit, all of that. However, as far as the Port of New York and New Jersey, that's, there is a zone of siting feasibility. There is a sort of an economic limitation to where they can manage this, and there's a reality that drives this need for the site. But all of those, sort of the relative merits of any one alternative will be weighed in terms of its impact, including, its potential to improve conditions or make conditions worse. You're back on mute, Jack. Can you unmute? We can't hear you, Jack. You're on mute.
Can you hear me now?
Yes.
Okay. Will EPA continue to avoid dropping dredge material on shipwrecks or natural rock formations?
Yes.
Okay. I have no objection to dropping it on a shipwreck area if there's no shipwreck there.
That will be fully evaluated and then documented in the review. Any decisions, any siting decisions, we will do that, and we will be coordinating with the cultural resource agencies on those decisions as well.
I would be in favor of creating a area that looked to be south of the Hars if they put down a lot of rock material, which tends to make good habitat for fish. Although I do understand what the commercial fisherman was saying. Thank you.
Absolutely. Thank you so much, Jack. We have a comment or question in the chat from Maureen. Is there any intent or chance that future dredge material dumps would reduce the depth of the water in any location to less than 75 feet? There's another, but I'll separate that out. Pat or Lindsay, do either of you want to speak to the depth limitation?
Do I?
Sorry, no, we'll handle the depth limitation, Jack. I was going to see if Pat or Lindsay on our team wanted to take that question.
Sure. So the 75 feet you saw on that slide was to allow for mounding of material that would not cause navigation hazard or the potential for resuspension of material. So we have some studies showing that 65 feet would be, we would not want to go above that to avoid that resuspension of material. And I believe navigation hazard would be 45 feet. So we would be staying below those. And Mark, if you want to add to that, please do.
Yeah, I mean, I would just clarify further. It's 55 feet is what we probably would be wanting to stay below in any case for navigation concerns. However, before we get to that height, we have concerns about the stability of material on the bottom. And so we need to sort of sharpen our pencil on it, but the operating depth based on the original designation was 65 feet was stable for fine materials. Coarser materials could go higher than that. In no case would we place material shoaler than 55 feet. But the wave climate and the storm climate may have changed since the time of the designation. So we are going back and revisiting that data to make sure that 65 feet is still a good sort of design depth for stability of fine grained material.
Great. And then Maureen had a second part of her question, which is, do you need all three proposed areas, or would one satisfy the future needs for ocean management? And I'll just say that the areas that were outlined in the zone of siting feasibility, the 3 polygons that Lindsay spoke about, are areas under consideration in response to the request for ocean management options from the Corps. And while they're certainly part of what we're considering for the development of this environmental review document, they're not necessarily a proposed area that we are planning on, that we're giving equal consideration to, as well as the HARS. But in terms of the demand and the capacity of dredge material that the Army Corps has outlined, our full analysis of the area that we will need will be addressed in this environmental review document, which will also have a public input and participation component to it. The frank part of that is that that those 3 areas are very large areas, and any alternative would only utilize some smaller subsection of those areas or the HARs. And I believe Cindy had her hand up.
Thank you. Those answers.
Yeah. Cindy, I saw that you just rejoined and that you had had your hand up earlier. Did you have a question or a comment?
Yes, I have a couple. Hi, sorry, I can you hear me?
Yeah, we can hear you.
Okay, great. Sorry, my computer dropped out, so I'm on my phone. So first of all, thank you for the meeting. It's great seeing some of the band get back together again. It's been a long haul from the 90s when we were really challenged with some how to manage mud in an environmentally sound way. And many of the folks on the call and not on the call were very instrumental in and collaborative strategy and commitment going forward. And I'm sorry I missed the first part of the meeting, but I did hear much of what was planned, and I think we're close. I think we really need to make sure that we move in the positive direction of finding the least environmentally harmful way, and to more to the point, continue the really successful and from a national, maybe even a global perspective, creating of a model that really works to use dredge material depending on its quality for better use. I do have a couple questions, and I think they're mostly from the presentation that the Army Corps made. I just have there was an assessment made of the radius for the material that would be generated. Is that radius the same radius for the existing dredge material management program for the region?
Hi, Cindy. This is Arsheen Hatasham.
Hi.
Hi. So I think what we looked at is currently how we operate. So what kind of equipment we use now, and that's kind of how the information and all those different parameters that we use to develop that radius now. There, as of now, when we talk about our current operations, we don't necessarily work with a radius necessarily. For each project, there is an evaluation of alternatives that is done. But specifically with regards to what was presented, it's an exercise that we did as part of our request to EPA to look at the equipment that is used now, the kind of operations that we do now with our different maintenance projects in the New York, New Jersey area, and all the different channels that we're maintaining. So I won't necessarily speak to say that's there's an existing radius that we are referring to. But I'll also give it a second to Kelly Vega to see if she wants to respond, or if you have any. That would be our response. Does that answer your question, Cindy?
Well, perhaps. I mean, I know that determining the volume of material was always a very, was very, had a lot of discussion around it. It was because there's a need to dredge, and then there's a want to dredge. A lot of places want to dredge, and then there's the need to dredge, and how, what are the limitations? Is it the navigational dredging depth as authorized by Congress? Is it because somebody wants to buy a big boat and wants their berth dredged to a certain greater depth? I mean, I'm just curious as to how the determination of need was developed in, and what was presented was this radius, which looked to me from basically a little bit south of Long Branch. So is that to over to maybe Breezy Point? I wasn't quite clear on the zone of area that you were looking at, from which you determined that there'd be about, and that was one question I had as well. In fact, yes, thank you. Putting up that slide is helpful.
So yeah, actually, I'll take a step back and kind of give you a little bit of background. So what we talk about in terms of our need, that's the areas that are as part of our area, our radius of work with New York District's jurisdiction. So what we are involved in as part of our operation and maintenance, all the different federal channels that I had shown on an earlier slide, the need comes from those particular projects. So when we talk about our new work, our harbor deepening efforts, our maintenance work, that volume of need primarily comes from those projects. As you captured, Cindy, the congressionally authorized depths that we maintain the channels to. What we are looking at here in terms of the zone of siting feasibility is with all of those maintenance projects, with all those different projects that we're talking about, how far away can we go and still have a operationally sound, meaning to say, like, how far away can we go and still be able to conduct a project? So for example, if we're talking about a project in the middle, in the New York, New Jersey channel, if it takes us 10 hours or so or more to go away to be able to manage that material, that project may not be able to move forward. It may not be operationally possible to move forward with that project. So this radius is how far away we can go from a project in order to still be able to manage that material. So there are two different kind of areas that we would talk about, one being our jurisdiction and one being this radius of to be operationally feasible.
Yeah, I see. Well, I think that, perhaps that's a part of the discussion, because some of the material further south along the Jersey Shore or further east on Long Island, that material might not need to be managed by the Army Corps of Engineers New York District in the context of, the ocean or HARS management. That material may be cleaner and may have options. I know we did a dredge material management plan for the Northern Bayshore region in New Jersey, for example, and there are other, beneficial alternative assessments for dredge material further south in the Navesink and the Shrewsbury. So, I just, in developing the concept for how much space you need or for how much dredge material you're going to be generating, I think, that sort of, that it perhaps could have further discussion, I guess, is the bottom line as the process moves forward. Because the goal is to minimize the amount of material that actually has to go out into the ocean, if it can have more beneficial use closer to where the material's being generated, which was one of the outcomes of that work we did so many years ago. Was, the closer you can find alternatives to the source of the dredge material, it's more, as I guess the word terminology is, native or more localized and could have benefits. So I don't want to belabor the point. I know probably other folks have questions, but I do want to understand how you came up with the numbers that you did. And then so that was helpful. And then the second half of it, I'm glad you put that slide back up because I was going to ask you to do so. I guess I'm curious as to, so this 18 cubic yard material for operational, then this chart is based on how much material for the,
The 20-year.
so you have operational dredge material management. It's going to cost maybe $469 million. How many cubic yards is that estimated for?
Yeah, so Cindy, that's looking at our projections with the overall of 51 million cubic yards that we were looking at as the need going forward. That takes a portion of that. That would be the maintenance material, only the muds and the silts. And I believe that estimate there on the previous slide was based off around 26 million cubic yards. So that's for the operation and maintenance. It's based off of our 20-year projection or projection of dredge volumes.
Okay. It would be helpful for maybe Thursday's presentation for there to be a little more clarity for that, some of the numbers maybe to be compared or added to the chart, just so that I can understand what you're estimating to be the amount of dredge material for the costs that you're identifying. And I just think I'm not following the charts that, and it may be just because I don't have to go back and forth to them. And I guess when we get the slides or we get the presentations, but it would be helpful to maybe put some more clarity in that.
Cindy, we can definitely add more information to the title and the chart to make it clear to everybody what the volume is based on for these numbers.
I appreciate.
Yeah, thank you.
I really appreciate that. Thanks, because that's a big that's a big part of the story. And I do want to also say that I know these cost estimates can get people kind of eyebrows raised, and I think that one of the things that is not appreciated is the benefit of the beneficial reuse, right? The habitat that you're creating over there on the western edge of the HARs, that the fishermen are out there, they're fishing, they're catching fish, we're creating habitat. There's an economic a value for that. And so while, that is a more inexpensive way to place material, there's also an economic benefit. And I know the Corps doesn't necessarily allow for that to be brought into the picture, but it gets even more impressive when you look at some of the upland remediation that's happening thanks to the dredge material and the amendment that's being done to the dredge material that allows for contaminated land to be put back into use by the public. And whether or not we needed another mall or we wanted a golf course, for two examples for the Jersey Gardens Mall and the Bayonne Golf Club, I mean, those are generating huge economic returns. And while there was an investment there up front for those alternatives to be implemented, they returned land to public use, they're generating jobs, they're generating tax revenue, they're generating income. And the contaminated mud did not go out into the ocean and did not contaminate the ocean, causing further harm to marine life. So I know that doesn't get added in, but I just really want to emphasize that because it is an extraordinary part of the story. And I think it feeds into what Mark was talking about with the future of what we plan to do. Hopefully not find a new ocean disposal site, but continue the work that has been done and try to continue utilizing the HARs as is practical and possible, and then perhaps finding some beneficial use consistent with what the fishermen and diving community wants as well. So anyway, that's my
Cindy, thank you.
comment.
Thank you so much. I just quickly wanted to address two things, just to kind of in quick response. Number one, I'll mention that, yes, the Corps is definitely committed to beneficial use. Something that Kelly had mentioned at the start of the meeting is our beneficial use goal. We have a beneficial use philosophy from General Spellman that requires us to have the 70% beneficial use of our dredge material by 2030. And here in your district, we continue to keep that as a priority. And secondly, I definitely agree with you. As part of our dredge dredge material management plan operations, our effort, that report that we have prepared, we did go into a great detail about beneficial use being a priority, and where our different options are when it comes to placement within the New York Bight. Here, we did a qualitative assessment. We've developed a framework looking at, what our different beneficial use options are and ranking them as well. I would invite you to take a look at that report, as well as published on our website. But we do kind of capture those elements that we are just as passionate about here, and kind of wanted to bring your attention to those items as well.
Okay, well, I will take a look at that. And you might want to put some links, make them more available. And I think it might be helpful to emphasize that in those charts that you're talking about, when you're talking about, expanding ocean, a new ocean dump site, or, the needs that you just talked about, because it just looks like we have ocean disposal at HARS, or we have upland. So it didn't really highlight the beneficial use. And I hear what you're saying. I read those reports, or some of the beneficial reports, and I don't know if this is a new one or not. And I appreciate the goal, but it doesn't really jump out at the might be.
So we cut out a little bit there at the end, Cindy, but
sorry.
we heard. Oh, are you back there?
I think so.
Oh, there you are. Yeah. But I think we heard the end sentiment to your comment, and certainly the Army Corps and the beneficial use mandate, and those sort of economic benefits to beneficial use have been considered, and we'll make an effort to wrap those more specifically into the presentation for Thursday. That kind of segues
That'd be great.
into, yeah, that kind of segues perfectly into a question from Isaac, which is, what is the process EPA is using to evaluate designating dredge material beneficial use sites outside of the HARS, which Mark, I'll bounce that to you if you want to jump in that real quick, since you covered sort of some of what we're considering in terms of the alternatives.
Yeah, thanks, Nick, and thanks for the question. So the process for evaluation of the alternatives, as I outlined in one of the slides, I think there's, first of all, there's two different things that we've been considering to date for inclusion in this review, and one of the beneficial uses is, is there an opportunity for further remediation of additional areas within the study area, using dredge material, and so it starts with, like, which we've done some of it in designing our monitoring studies, a review of what does the sediment look like out there. We're looking for fine sediments. That's what tends to harbor the contaminants. We know that sand is sand. Sand tends to be clean. It doesn't bind contaminants. That's not where we're going to find contamination problems. That review was conducted, and so we identified areas that that there was evidence that there would be fine-grained sediment there, or we went and visited areas that were adjacent to or within areas that have been previously used for past disposal practices. And we conducted sampling there, and we will be looking more closely at the data to determine whether there's an opportunity for reducing concentrations of contaminants in those areas using dredge material. So in some cases, we may find that conditions are perfectly acceptable. Other ones we may find they're marginally increased, but we need to be confident that a dredge material placement strategy there would result in reductions that are worth the disruption to that area. So that's sort of the evaluation that we would have to do in that case. I think the question of constructing habitat using the deepening material is a little bit sort of broader. I think that's really a matter of, you know, very close coordination with other users. In particular, I think one of the main ones is the fishing community and the seafood industry. You know, to make sure that wherever we do it makes sense, that it's not an area that's actively fished, that we would be actually adding value. I think that there's a lot of unanswered questions as to how to best do this. And I think, you know, one of the things that we would have to as a community accept is that we'll kind of learn as we go. But the thing that makes it a little bit different is if we can decide on an area to construct this, which is not a given, we may not be able to resolve the optimum siting of a feature like this where we get broad acceptance of it, is that also I think as a community we'd have to understand that there's a lot of uncertainties as we go in, and we're going to have to answer them as we go with close monitoring and close coordination and adaptive management. And that's, you know, that's one of the benefits of, you know, or one of the differences, and I would say benefits of what we're talking about when we talk about a construction project, a habitat construction project, is that one, it would have to be formally designated under MPRSA, which means that we have to have a requirement for monitoring and management, which means that the federal government has to actually implement that plan. So we can come up with what is the monitoring and management strategy, you know, subject to revision. We can always revise the site management and monitoring plan in conjunction with our stakeholders. But the point is, many times when we talk about these types of efforts, it's sort of a one and done where they say, here's the design, we're going to go build this. Hopefully it works, fingers crossed. And they build it, and sometimes it's successful and sometimes it's a failure. Under this process, it would sort of be built over time as material became available, and it would be monitored, guaranteed to be monitored. And, you know, we would have an opportunity with the right group of folks on the scientific review panel to assess that monitoring information, inform how we want to go in the future, you know, with additional placements, including, you know, there may be things that we say, oh, that's not quite functioning the way we wanted, where we built it a little steeper, it seems to be doing better, let's add material over here, et cetera. So that's a big difference, is that it's not a sort of design it at the outset, assume we know everything, and then, you know, walk away, and then the money dries up and there's no more monitoring, and that won't happen under this scenario. So, you know, evaluating it, you know, I think there has to be a process that we go through before we get to citing it and further studying it. I think that anything that happens outside the site outside the HARS is going to need further coordination to make sure that a broad array of stakeholders is comfortable with the proposal. So I'm sort of talking around in circles now, but in any case, I hope that answered the question, Isaac.
Great. Yeah, Mark, I think you highlighted that, you know, there's like an adaptive management plan and strategy in place, and that whatever would exist as an alternative under consideration would be an iterative process and would you know, require continued stakeholder engagement, which kind of feeds into, again, Scott's question about whether dredged sands can be used for beach replenishment to minimize damage being done to sand shoals in close proximity to the beach. And maybe Arsheen, you could speak a little bit about, you know, in terms of how sand can and is prioritized for beach nourishment, and how that relates to some of this decision making.
Yeah, sure. So I think one of the key things that we noted as part of our efforts to prepare the dredge material management plan update was that a lot of the sand that is generated that we're targeting, and that's in areas where we're maintaining the shoaled areas. We continue to use that sand for, you know, beach replenishment for near shore areas, for placement in our Sandy Hook Borrow area, which is then from there eventually used for continued beach nourishment as well. For a lot of our projects, it's usually a more economic and beneficial use to use that sand for renourishment purposes and for beach placement purposes. Typically, it's the finer the silts and the clays and the muds, as we are referring to them, that go out for other alternatives, for other placement alternatives. But yeah, I think we covered this evaluation as, again, part of our dredge material management plan update assessments. And I would, again, like to kind of refer back to that document that does include a good detail of our breakdowns as well.
Sweet. Thank you, Arsheen. Scott, did that sort of get at the distinction between sand that gets prioritized for beaches versus what shoal building that is being sort of broadly discussed here might entail?
Yeah, I don't want to waste your time here, guys, but down south, and I know it's outside of the district, we're regularly taking sand out of channels, dumping it just outside, the inlet, and in a short period of time, it's washing back either in or back up onto the beach. And all we're trying to find is some way to get some longer use out of this instead of just dumping it as close as you can on the other side of the jetty. So
Yeah, no, we hear that for sure. Unfortunately, in terms of the discussion presently, that does fall under sort of more of the jurisdiction of the Clean Water Act, and not under the jurisdiction of MPRSA in terms of the beneficial use in the ocean. However, that process and that comment is certainly resonates and recognized and is very valid in terms of the context of the conversation, because the decision-making process, as Arsheen highlighted, about what where sand can go and when it can go, is really important to what we're talking about. In terms of uses, sorry, did somebody have anything they want to throw in there?
Yeah, I was also going to say, it's Pat Petchka. That's and you mentioned it. It's South Jersey, so it's Philadelphia district, and it could be a cost sharing issue. On top of everything, if it's got to go on the beach, the locals may have to come up with some of that money to get it onto the beach, and it is a shame when they are just pulling it out of the inlets and side casting it and letting it go to back in the littoral zone or whatnot. But it could also be a local cost sharing issue or state cost sharing issue for that. So
there's
just trust that.
Yeah, there's a whole host of issues there. I don't mean to open up a can
Yeah.
of worms, guys. I want to keep you on topic, but thanks.
Thank you. So Leah had a question in the chat. If areas within the additional locations, these areas A, B, or C, which are those polygons that we highlighted, are determined to be an option for ocean placement, what is the process for determining where within those areas the placement location would be, as there may be other conflicts or potential future conflicts that are not considered in the desktop analysis. Lindsay or Mark, do either of you guys want to take that in terms of discussing the what type of hypothetical decision making would happen in that scenario?
Well, I guess just let me sort of jump in here. I mean, I think we are what Lindsay has done is looked at the available data sets that allow us to assess the conflicts that we can sort of get our minds around and get our hands around, and that's the net result of that. That I don't want to call it an exercise because it minimizes that undertaking, that huge project that Lindsay did. So we came up with these areas that, generally speaking, there aren't major conflicts there. But if you take a closer look at these slides and you look at area B, for example, when they talk about the go up to slide, I think it's 35, if you can do that. The one with the, there you go. That's difficult to see there, but the upper left-hand corner, so this shows some fishery usage layers that Lindsay considered. So within Area B, there's actually a New Jersey prime fishing ground within that area. So it's not to say that there aren't conflicts even within these greater polygons. These are just the areas that we identified that minimize conflicts overall for closer study and for more focused siting, consideration. So in the case of that, we already know that there's a conflict there. There could be, pipelines or things like that we don't know about, but in fact, in the lower portion of this polygon, there's actually a conflict with a planned cable route for wind energy. So that type of thing might come out as well. But I think, sort of in short, we are in the process here that you are referring to, in which we are soliciting comments from folks so that if we can, anything that we can't, readily attain, that we can, get from the public additional information about some of these areas so that you might identify to us a conflict that's here. So that may be, fishing data that's not captured by VMS or that type of thing. Those types of sort of individual sources of information are very important for us to hear, and really is what drives the reason why we need to go out to the public and not just trust our own review of publicly available information, but rather to tap into the personal concerns or sources of information that people have. So in short, we're in this process. I think we will take this information, we will further evaluate concerns and contributions from this public scoping. We will complete our evaluation, and then we will go out with a draft document again, and there will be an additional opportunity for folks to understand how we may have narrowed down our list of alternatives or our citing of those alternatives, and then there would be another round of reaction to those. And so I don't know if that explains it, Leah, but I mean, essentially, that's why we're talking to you. Is we want to hear any concerns that people might have about these. Even if we don't go forward with a certain area, it's important to know that that there's something there, because if we choose a different polygon as preferable, and then people come out after the fact, we really haven't achieved what we want with this process. So please share, consult with whoever you need to consult with. And try to get us these comments by July 14th so that we can consider them initially, and we can avoid any any sort of problems back at the back end of the evaluation.
Thank you, Leah. Cindy, yes.
Thanks. Sorry, I don't want to dominate the conversation, but Mark, you had raised the polygon, the options there, and when you presented the 4 alternatives, one of them was to designate a new dredge material disposal site outside of HARS, and that's something that you're not necessarily looking at, but of course, we're happy about that. Certainly like to know what we can do to help affirm that that's not what's going to be happening. But
That's
if it
not
is
what's
a
going to
part
be
of,
happening. That is not what's going to be happening, Cindy.
Okay. Can we
You
take
got it
that
on,
to
you got it
the
on record here. It's not
proverbial?
what's going to be happening.
Okay.
I mean, that's the one that
All right.
we are making sure that we project right now. It's not an alternative. It will be listed as something, and you will hear the exact same reasoning as to why it's not going to be considered further in the evaluation of alternatives, prominently up front.
Okay. So as the NEPA process would go forward, I guess I hear you, and that's wonderful. There's the but there, that there's a potential. So if there's a way for that to be clear, that's not, that's kind of off the table. I don't know how you do that when you're doing the NEPA analysis and presenting the alternatives, but that would be great.
Please submit that comment that you would be very opposed to that alternative. I mean, that's what we're looking.
Right.
That's what we're looking for. I mean,
Okay.
yeah,
And anyone else on the call that feels similarly, be sure to emphasize that. Just doing a little lobbying on the side, guys. It's my job.
we accept letters of support for alternatives as well,
Good.
for other alternatives.
Great. And that's again why it would be really helpful to have a little bit more detail on, the HARS, and in this one presentation, like the categorization of them, is it, with the presentation of the need that you have and the size of the challenge that you have in the next 30 years, 20 years, how much of that is expected to be category 1, how much of that is not, a little bit more detail would be helpful.
That's great.
Thank you.
Thank you, Cindy. Yeah, so, as Mark and Cindy actually just highlighted for us, we're coming up at just after the hour, so we're going to try and wrap things up. If anyone has any last questions or comments, go ahead and throw your hand up. But again, to reiterate, this comment round is to gather your input to help us develop this environmental review and the alternatives for the continued management of dredged material in the New York Bight. There will then be the generation of that document, where there will be another round of public comment before the final document and rule are made. Please, again, submit your written comments to the email listed on this slide, region2_MPRSA@epa.gov by Monday, July 14th at 11:59 p.m. I'm going to throw our website into the chat one more time. Oh, thanks, Jordan. Yep, just put that into the chat. So you can find all the relevant information, the slides from this section. Once we make those updates that have been requested to the slides, those will be posted on the website for your reference. And we look forward to incorporating all of your comments and interests into the development of this document. Thank you guys so much. Unless anyone has any final comments, we will wrap the session up, and we will see you back here on Tuesday for a second round. You're welcome to come by again. Thursday. Today is Tuesday. Thank you so much. On Thursday at 4 p.m.
Thank you.
Thanks so much, everyone. Have a good evening.
Thanks.